Integer operations, the basics of positive and negative numbers. First, let's talk about the elephant in the room. Why do we even have negative numbers? After all, we got along just fine without them our first few years of school. We learned to count from 1, 2, 3, 4, all the way up to a cajillion, or so our 4-year-old selves believed. We learned the idea of zero, or nothing. Then someone decided we should be able to talk about parts of something and came up with fractions and decimals. The horror. But no one warned us about the torture they'd throw at us next. Negative numbers. Don't worry. Just like we learned that fractions, upsetting as they are, have an important place in the world, we'll soon come to appreciate the usefulness of negative numbers. As with most concepts in math, there are many applications for negative numbers. The most basic application uses negative numbers to represent a decrease in quantity. For example, if you start with $20 in the bank and you spend $5, your bank account's history will show a transaction of negative $5. We now understand why we need negative numbers, but what do they really mean? Remember when you were first learning to add and subtract and you used a number line to help? You probably remember putting your pencil on the number 3, for example, and counting 1, 2, 3, 4 places to 7. 3 plus 4 is 7. Then you could move 1, 2, 3, 4 lines to the left back to 3. 7 minus 4 is 3. If you've ever moved on a number line to practice basic subtraction, then you've already used negative numbers. What we know as subtraction is really the same thing as adding a negative number. Let's shift our number line a little bit, shall we? Our new number line has 0 in the middle. To the right, positive numbers. To the left, our new friends, negative numbers. They've always been there, they've just been a little shy. We're going to start at 3 again for consistency, but this time we're going to subtract 5. Now if we move 1, 2, 3, 4, 5 spaces to the left, we find ourselves at negative 2. Okay, so math is weird, and you can keep subtracting even when you run out of something. But you can't do that in real life, right? So why does this stuff matter? Remember your bank account from a minute ago? You started with $20 and spent $5, so now you have $15 in the bank. Imagine you then spend the remaining $15 and a little extra. Now you owe the bank money and your balance is, let's say, negative $2. That means the next $2 to go into your account don't belong to you. They belong to the bank. Negative numbers can be used in real life to show that we don't have enough money to cover our expenses. This is sometimes called a deficit. Negative numbers probably seem a little daunting, so let's talk about how we deal with them. We need to know how to perform operations with combinations of positive and negative numbers. We've had some practice with addition and subtraction, so let's take a break from that and look at multiplication and division. Here are some rules to help. When you multiply two numbers with matching signs, whether they are both positive or both negative, the result will be a positive number. 3 times 5 equals 15, and negative 3 times negative 5 equals 15. If the signs don't match, the result will be a negative number. Negative 3 times 5 equals negative 15, and 3 times negative 5 equals negative 15. But what if you're multiplying more than two numbers? Count the signs. If you have an even number of negative numbers, the result will be a positive number. If you have an odd number of negative numbers, the result will be a negative number. For example, in the problem 3 times 4 times negative 5, there is only one negative number. If you multiply 3 times 4, you get 12, and then 12 times negative 5 is negative 60. The result is a negative number, negative 60. If we change the problem to -3 times -4 times 5, we now have two negative numbers. -3 times -4 is 12, and 12 times 5 is 60. The result is positive 60. Let's go back to addition and subtraction. Earlier, we learned that subtraction is the same as adding a negative number. Instead of 12 minus 7, think of it as 12 plus -7. If we get into the habit of looking at problems this way, we'll be able to learn a couple of simple rules to help us deal with addition and subtraction in the same way. If all the numbers we're adding are positive, the result will be positive. If all the numbers are negative, the result will be negative. But what if we have a mix of both positive and negative numbers? How do we know if the answer is positive or negative? The answer is in the absolute value of the numbers. Let's take a look at the problem 4 minus 12. First, we'll rewrite it as 4 plus -12. Now we can see that we're adding a positive and a negative number. Which has the larger absolute value? Remember, absolute value means we're looking at the size of a number without looking at its sign. So which is larger, 4 or 12? 12 is greater than 4, so in this case, the negative number has the higher absolute value. The result of 4 plus -12 will be negative. Next, we'll need to find the difference between 4 and 12. The difference is 8, so our final answer will be -8. I know this may seem like a challenge right now, but with practice it gets easier. Let's look at one more example. What if we have more than 2 or 3 numbers with mixed signs? We'll take the expression 4 minus 7 plus 9 minus 6 minus 3 plus 5. It's not pretty to look at right now, but I can show you an easy way to handle this. Just like before, we'll rewrite this as an addition with negative numbers. 4 plus -7 plus 9 plus -6 plus -3 plus 5. Now, we'll group the positive numbers on one side and the negative numbers on the other side. Then we'll find the sum of the positive numbers and the sum of the negative numbers. Our expression is now simply 18 plus -16. It's not so scary when we look at it this way, is it? We could look at this now as 18 minus 16, which is something that most of us are comfortable with. When we take the absolute value of 18 and -16, 18 is greater. This time our answer will be positive. The final answer is 2. Take a deep breath. You've now mastered the basics of positive and negative numbers. Don't forget to keep practicing so you don't lose your edge. If you need more help with these concepts, check out the integer operations examples video.